Growing a better world together. Rabobank.
Welcome back to the second day of JSpring Digital. We're now getting ready for our second talk. Don't forget to join our chat where you can ask questions to the speaker and discuss with other participants. Now it's time to announce and welcome our next speaker, Trisha G. She will talk about upgrading your trusty old Java 8 application to a newer version and how you should do it. Welcome, Trisha.
Hello, thank you for having me. Yes, as you said, I'm going to be talking about basically why and how to upgrade your code from Java 8. Because it's not just a case of how, it's a case of what has happened since Java 8, what's involved, and why might we want to make the changes. So typical, I press the buttons and nothing works. Right, so according to the JetBrains Developer Ecosystem Survey, the survey was done last year, the results came out earlier this year. About 75% of people who are using Java are using Java 8, of the people we asked, obviously. And then about 32% are using Java 11. Obviously, these numbers don't add up to 100 because the people are using more than one version of Java. But you can see that Java 8, even now, even with Java 14 being the most recent version of Java, Java 8 is the most commonly used version of Java. This is down 10% from last year, but it's still a significant number of people. And if you look at other developer ecosystem surveys, they say the same sort of thing. The majority of people are using about 80% of people are using Java 8. A chunk of people are using Java 11, and most other versions have just a smattering of users one way or another. That was the New Relic survey. This one was a super scientific survey I did over Twitter where I asked people, like, which version are you using? But you see the patterns are the same. Generally speaking, a bunch of people using Java 8, a chunk of people using Java 11, and almost no one using the other versions. Let's take a look at some of the reason for this kind of weird distribution. You might not quite get why a lot of people are using 8, a lot of people are using 11, but people aren't using 9, 10, 12, 13, or 14. So this is all down to the new 6-monthly release cadence. Ever since Java 9, we have a new version of Java every 6 months, which I think probably the majority of people by now probably know. So we get a new version of Java every 6 months, which is why we're up to Java 14 already. However, what might not be so clear is we have two types of releases now. We have releases, normal releases every 6 months, and long-term support releases, which are every 3 years, nominated every 3 years. Java 8 was a long-term support release. Java 11 is a long-term support release, and probably Java 17 will be a long-term support release. So if you look at this picture here, you're basically seeing each of the small releases has a 6-month window where it is supported, and only Java 11 and Java 17 are supported for a longer period of time. It's important to understand that this is the story from Oracle. Now, the majority of us have been using an Oracle JDK probably since forever. You go to, you say download Java and you get an Oracle JDK. Oracle changed a lot of their licensing and a lot of their support plans since Java 11. So it's important to understand some of this has changed, and this might impact you if you want to move from Java 8 to a more recent version, particularly anything from Java 11 onwards. So there's a few things. One, Oracle will charge you for long-term support of these releases, and also two, that these 6-monthly releases only sort of last for 6 months, then you have to move on to the most recent one. So basically you have two options when you're upgrading, particularly from Java 8. You can use the free Oracle Open JDK, which lasts for basically for 6 months, and ideally you will upgrade every 6 months. So when Java 13 came out, you stopped using Java 12, you start using Java 13. On this cadence, you'll be using Java 14. This is the most recent version of Java. It came out in March. Your other alternative is to use a long-term support version, which you may or may not have to pay in order to get the support in production. The Oracle story is you have to pay, but there are a bunch of other vendors as well, which I'll talk about in a minute. So if you want to use a long-term support version, then you're looking at upgrading from Java 8 to Java 11. And this explains why people are generally using Java 8 or Java 11, and not so many people are using the other versions of Java as we go. Now, I mentioned that this is the Oracle story. There are a bunch of other vendors. This is just a very, very small list of probably the most famous vendors. So you can get a JDK from pretty much any of these. They're all based on OpenJDK, which includes Oracle's JDKs, also based on OpenJDK. So they're all functionally the same. You can get exactly what you expect from any of these vendor releases. The difference is in what you pay, the support cycle, which platforms you can use it on, and so forth. My advice, if this seems a little bit confusing, and this is not legal advice, not legally binding, I should have like an Oracle style slide saying, don't listen to advice from developer advocates. If you're not really sure, I would take a look first at Adopt OpenJDK. This is a community-run project to build OpenJDK for free for people to use, and it includes, or it included last time I looked, it includes the idea of long-term support releases for 11 and 17 going forward as well. Last week, so we managed to time this very well, last week it was announced that Adopt OpenJDK is now moving to Eclipse Foundation. I personally think this is probably a good thing, because this makes it a nice sort of, it comes under the Eclipse Foundation umbrella. It means it's going to be a proper open source project with technical steering and so on and so forth. So keep an eye on this. It does mean Adopt OpenJDK will from now on, or once it's adopted into Eclipse Foundation, it will become Eclipse Adoptium. Apparently, I don't know how long that name's going to last for, but hey. So all of that said, we have a whole bunch of release cadence changes, a whole bunch of licensing changes, a whole bunch of different vendors we could get our Java from. So it does kind of beg the question, why bother? Because a lot of people are very happy with Java 8. Streams and Lambda expressions did manage to plug a hole in the language, and people were very happy to kind of get that functionality, and it's nice and stable. It does what I want. Java 8 will be supported for quite a period of time going forward. So I'm not really sure why I should bother to figure out whether I want to update every 6 months or every 3 years or whatever. So let's take a quick look, it's probably not going to be quick. Let's take a look at the language features in Java 11. I'm starting with Java 11 because this is the current long-term support release. I expect most enterprises will probably be more interested in adopting a long-term support release, i.e. Java 11, than in one of the other ones. So in this section, we're going to go through all the features that have come into Java since Java 8 that you will be able to find in Java 11. The first, I was going to stop for questions actually, wasn't I? Can we have questions at this point?
We have one question. Would you not recommend using LTS, long-term support?
Would I not recommend using LTS? Like I said, I think for most enterprises, they'll probably want to go for an LTS release. I think the reason to not go for LTS is if you want to use Oracle OpenJDK for free in production, then you'll use the most recent six monthly release version, in this case 14. The other reason you might want to not use an LTS is if you want the most recent features, basically. So if you want the stuff that's in Java 14, then you can't use Java 11. So those are the two main reasons. One, you can use a free version of Oracle's, and two, you can use the most recent version of Java. I certainly wouldn't recommend using the in-between releases which have been and gone. So Java 9, Java 10, Java 12, and Java 13, don't use those now. Use the LTS or use 14.
Yeah. Thank you.
Okay, so yes, so let's move on to the language features in Java 11, the current long-term support release. JShell. Let's have a quick look at JShell. JShell came in Java 9. It is the REPL for Java. I've been a long-time Java developer since for about 20 years, which is quite frightening. So I've not really used other languages in the last 10, 15 years. So I'm not really that familiar with a REPL. But if you have used a REPL from another language, or if you do want the idea of playing with new features in a nice safe sandbox, the REPL is a good place for that. So let's take a look. So I'm going to start mine up by going to, well, actually, let's look at Java 11. Java 11 home, bin, JShell. And then you get to the REPL. The first thing you'll notice is that because it's in the bin directory of my Java home, it is not tied at all to the version of Java that you're using in your application. It's not at all tied to the version of Java that you're using in production, in continuous integration. Like, you can run it locally, whichever version you want, and have a play around with it. I happen to be using 11.0.6 apparently. So the REPL allows you to do I get code completion. I can press tab and get code completion, which is what I like because, you know, I work for an IDE company. I'm kind of used to getting tooling support. So I can say system.out.println. I get code completion, which tells me which are the options available to me. I want println. I can say hello. And oops, and I can, oh, what happens if I do an error? What does it tell me? It goes unclosed string literal. Fine. So I can do that. The most exciting thing about JShell is the ability to write Java without using semicolons on the end of the line. Yay, so exciting. So anyway, so you can try stuff out. So for example, you could try out some of the new features, which I'll talk about later, like var some value equals, I don't know, my name. And then it will assign you some values, and then I can say, let me see if I can remember what it is. If I press slash and tab, I get some commands that I can run. So I see what variables I have. I can assign some like anonymous variables. So now I can see what I'm building up here. I can create, I could do something like, see if I can remember how to do this. I can obviously declare methods. So I can say public void print, or let's say, and I can say system.println. There I need a semicolon. I close it off, and then I can call print. So fine. I can also do something like, if I can recall if I can do this correctly. Okay, no. Well, what you can do is you can do forward references. So you can start building up your, you can start calling methods that you haven't created yet. And it'll say, when you create this method, then the method that calls that method works. So it's actually quite, it's quite a nice complete piece of functionality. So I was using this to play with the collections factory methods, which we'll look at later, to see what are the different types of collections that I can create. How do they look? Can I insert values to them? So a lot of this kind of stuff that I previously would have done perhaps using a unit test or perhaps using a main method, now I can kind of play with it live in JShell. So it lets me play with stuff and figure out what's going on. You can also do things like you can export these things into a script file, and you can import scripts and run them and things like that. So there's quite a lot of there's quite a lot of options for different things we can do here. I haven't used it that much in anger, but every now and again when I do want to try something out, it is a nice place to try things out, especially if you want to try out new features in Java, but your current application is on Java 8 and you want to try some stuff from Java 14, for example. Right, so that's JShell. There's loads of stuff about JShell, so it's much more than just writing system.out.println. var, you already saw me use this. Let's look at var in a bit more detail. Let's go into my IDE. Oh, I knew I didn't want to do that. This is my blog, so I really would like to not have my blog open. Close that project. Fine. So what I want to do is, let's look at var. Now I can use var anywhere. I can, the idea of var is to replace this boilerplate with var. So let's say we had an example here where we have an array list person, list, array list person. There's all that boilerplate there, which people get upset about for whatever reason. And so now we can just turn that into a var. We don't need to repeat those types everywhere. Now, var is not something that I would recommend that you go ahead and use everywhere. In fact, there are some guidelines here which suggest some style guidelines for using var. The idea of var is it is a tool that you can use to reduce unnecessary boilerplate, whatever that looks like, and aid readability. But there are places where var may not aid readability. It might be masking things. So some of the guidelines are, for example, choose variable names that provide useful information. So if I turn this into a var, then it's not necessarily very helpful if I just see this, because var doesn't really mean anything. IntelliJ IDEA, by the way, this is fairly new. I can't remember if it's this version or the previous version. It will give you hints as to what this type is so that you don't get too lost. Minimize the scope of local variables. So if you turn if you turn this into a var, and then somewhere like miles down in the code you're doing something with that list, it might not be clear what that type is. So it's a good idea to use var when the initializers, which is the constructor or factory method, provide you with loads of information. So for example, input and output streams in Java are a little bit clunky and involved, so you don't always need all this type information. So I might just want to turn that into a var there. But something to be aware of is that it doesn't erase the types. This is not dynamic typing. This is about reducing the boilerplate where there was perhaps a duplication of types. So let's go back to this array list, for example. This has an array list of person with a new array list of person. So replacing that with var is exactly the same thing that it was before. Now, if this had been a list of person, then I don't think IntelliJ suggests it actually. No, IntelliJ doesn't suggest turning that into a var, because this list variable is of type list. But if you turn that into a var, this will now be of type array list, the explicit type. So you do have to be a little bit careful when you start introducing var. So you can't code to interfaces if you're using var. And the other thing is that, like I said, you have to have the type information somewhere. For list.of, and we'll look at list.of later as well. For list.of, the type information is here. This is going to be a list of strings. So if I turn that into a var, we still have a list of strings. This doesn't have any type information anywhere. So will IntelliJ do it for me? No. If I turn this into a var, then this becomes a list of objects. So that's a different type. So you do have to be a little bit aware of the fact that var is there to reduce the need to duplicate type information. But if you use it in a place where you're overriding the type information, you might not get the type that you want. So be aware that it can be helpful. So this is a good example of where var would be a good idea. This is a genuine example I found somewhere. So with generics and nested blah, blah, and I actually don't care, because for me, all I care about is that this is an iterator. I really don't care about any of this type information. So I really do want that just to be a var. And then I can just, well, no, I would expect to be able to hide that. Can I hide that? Right, I will have to find out how to hide that. So I don't really want any of that type information. I just want to be able to use it as an iterator. It doesn't matter to me. So that's var. It's a small thing. I do think it's interesting. I do think it's very helpful. What happened to where did Keynote go? There you are. I do think it's helpful. The goal of some of these features is to make code more readable. So if it doesn't make your code more readable, don't use it. It's as simple as that. Convenience factory methods for collections. We already saw a little bit of this with some of my examples for var. So let's take a look at this example here. Ooh, this is not one of the examples I wanted. So often in your code, particularly in Java 8 or earlier, you'll see something like arrays.asList. You can create a set list there, an upfront created list. So you can now do that with arrays.asList. Sorry, list.of. Will it suggest that there? Instead of that, you can do list.of, which might not seem all that exciting because all you do is you save something like 2 characters. But in actual fact, the difference is that arrays.asList, you can't add items to that list, but you can actually change the items in that list. But list.of gives you an unmodifiable list. So it means that anything that you want to do, which is always going to be the same, which in the case of my test data, I always want this to be the test data, and then I'm going to use list.of so I get an unmodifiable list. That's kind of fine when it comes to lists, but it's not super exciting. So let's look at some other examples, if I can find them. Let's see, what did I call it? I know what I'm doing. I've already made all these changes. Rubbish. This is not the right code. So in the real world, let's see if I can find an example. New hash set. There we go. That's what we want. Java 9 inspections. That makes way more sense. So in Java 8, anything earlier than Java 9, in order to create a set of values, which you might want to do for test data or even for your production data, generally speaking, you'll chuck it into a list, stick it into a set, and then if you're careful and you want to make it unmodifiable, you have to wrap it inside unmodifiable set, which is just a really horrible amount of boilerplate for something which should be a fairly standard operation. So as of Java 9, so therefore in Java 11, is the ability to replace it with a simple set.of. So that's just a lot easier if you're using sets, particularly for test data. You can do the same thing with maps. So you could be adding values into a map with a static block, which is kind of not super exciting. Again, we often forget to wrap it inside unmodifiable map, and that's actually often what we want to do. So oh my goodness, I keep pressing the wrong keyboard shortcut. So we can actually replace this with map.of entries, and then we could put in entries like this. So we have an entry, or we have a key value set. Now, this is what it looks like if you've got a lot of entries. If you have, let's get rid of some of these. You've only got a small number, anything less than 10 actually, then you have a map.of, and you just do key value, key value, key value. So that can kind of just reduce, again, some of the boilerplate, make things a little bit easier. It's not quite as pretty as, for example, Groovy's syntax for creating maps, but it is an improvement over what was there before. It's a lot easier for creating static data for testing or for your production code. It's very handy. I have used this a bunch since Java 9 came out. So why does Keynote keep disappearing on me? Come back, Keynote, all is forgiven. Next up, collecting to unmodifiable collections. You already know, if you've been using Java 8 streams, you can do collectors.collect, sorry, collect to collectors dot, oh my goodness, I cannot speak today, collectors to list, and that's usually what we do. But as of in Java 11, we can do collectors.to unmodifiable list. So we're building off the back of this the collections factory methods thing, the idea that we can by default set all of our data structures to be unmodifiable, which is a good thing. It's a good thing from a programmatic point of view, because then we don't get weird unexpected behavior with people modifying lists that we don't want them to modify. And it's a good thing usually from a performance point of view. If the list doesn't get modified, then you don't have so many worries in terms of multi-threaded performance, and we can reason more about what the contents of that list are as well. So using to unmodifiable list is a good thing to do. There are new methods on the Stream API, take while and drop while, for example. These are really helpful. So one of the things you can be doing, one of the things you couldn't do in Java 8 is start a stream, particularly an infinite stream, and say, do all of this until some condition is met. Which is something I've wanted to do a bunch of times. Now you can say take while, so you can process the stream until some condition is met, which is very handy. And you can do drop while. You can say ignore all of this until some condition is met, and you can combine drop while and take while, so that you can kind of get the bit in the middle if you want to. It's very helpful. And there's also stream.of nullable as well, which can be helpful too. We also have a predicate.not. It's just one simple static method. It doesn't sound super exciting, but it can be very helpful. Again, this is kind of in the Java 8 themes side of things. So let's have a look for, where is it? It's in Java 11, I think. Yeah, so predicate.not if you want to, in Java 8 streams, if you want to do something like filter for a not case, like I want to filter for all the strings which are not empty, then I have to use obviously a not operator, and I get to call the method. What I don't get to do is I don't get to put this in a method reference, which I might want to do. If I want to put this in a method reference, then I have to extract a whole method here. String is not empty. And then I can put that into a method reference. Apparently not today. Not today, thank you. Anyway, in as of Java 11, you can in fact say predicate.not instead. So you can start passing around your method references. I can even, if I want to, I can static import that as well. It's really just a stylistic thing. It's not anything to do with performance or what's better or what's not. It's all about how do you want your code to look, and just gives you another option if this is something which interests you. I thought this was not really a big deal, but when I was asking people what they liked about modern versions of Java, apparently predicate.not was one of those things that people liked. We've got new options on optional. I liked the idea of optional in Java 8. I really like the idea of having a type which explicitly says, if I call a method, then my return is you might have this value or you might not, and that's what optional was for. It also allows a certain style of programming. You can also do functional-ish programming with it because you have you can use it with Lambda expressions, but that was quite limited in Java 8. In Java 11, there are a bunch more methods on optional which allow you to use it in a more functional style. So let's take a quick look at those. Optional. So for example, again, this is more of a stylistic thing. Instead of saying not is present, which your brain might have to sort of try and parse, you can now quite simply say is empty. So it's a bit more readable. It just means that your brain doesn't have to not it for you. So that's one thing. It's just the flip side of that. You can say an optional or else throw, so you can specifically, this method will return the value inside the optional, do the get if it exists. If it doesn't, it will throw this exception. So it allows you, instead of just doing if present, you're basically doing the opposite. So if it's not present, this is the exception that I want you to throw. And one of the things I really like, one of the new methods is if present or else. When I actually try to add optional into one of my existing code bases, where actually it does do a lot of checks for null, I found that the Java 8 version of optional wasn't enough for me, because what a lot of what I did was, with nulls in particular, was if it is null, then I need to do something else. So I would have a lot of if then else's. Now you can do that in a more functional style now with if present or else. So I can actually pass in a Lambda expression for the thing to do if the value is not present. So it just makes everything a little bit more functional. Similarly, I can do or is a new method. So I can say this optional or this other optional. So all of the other methods are around the value that the optional wraps, the string, for example, but this one is about this optional or this optional, not this value. And we have an optional.stream, which allows us to use it inside stream operations in a slightly more useful way, particularly for things like flat map. So there's just some nice things in there which just make it a little bit easier to use in a functional way. It just kind of builds on the stuff that came in Java 8. How are we doing for time? Right, we are not doing great for time because I've got loads more stuff to do. Java 11 has a built-in HTTP client. This is kind of handy. I found a lot of people saying they like it for testing. I definitely want to convert one of my microservices applications to use the built-in HTTP client, because I think it's going to make my code simpler and easier. Another thing that came in, actually came in Java 9, so it's part of Java 11, is multi-release jar files. Generally speaking, us as enterprise application developers don't necessarily care about this, but if we're working on an open source project or a library, this could be very helpful. What it does is it allows me as a library developer to package up my library in a jar file, and that jar file will run correctly on your platform for whichever version of Java that you have. So if, for example, you're running Java 11, you can use my library will use your Java 11 features. If you're running Java 8, then my library will only use the Java 8 features. This is quite helpful. It's particularly helpful for library developers. And the nice thing about this is, often it's the library developers who are a little bit stuck behind when it comes to upgrading versions of Java. I definitely suffered this when I worked at MongoDB. A lot of our users were on Java 6, so we couldn't migrate the MongoDB Java driver to Java 8 at the time because we'd be leaving behind our users. Now, with multi-release jar files, library developers can be using the most recent versions of Java and sort of help, but still support the older versions of Java and help move people towards a more recent version in a smooth way. The big feature for Java 9 was Jigsaw, which of course we're supposed to call the Java module system. We're not supposed to call it Jigsaw. This might not seem super exciting to most developers. We are either using something like microservices to develop modularity, or our build system, or some other way of creating modular systems. But it does lead to some interesting results. The fact that the Java module system exists, the fact that the JDK itself has been modularized, allows us to use just the bits of the JDK which are of interest to us. So we no longer have to deploy our Java application with the whole JDK, with everything that comes with it, with all of the old stuff that no one's ever going to use anymore. We can, for example, use a tool called JLink, which will allow us to compile just the bits of Java that we care about, package it up into our application, and create much smaller deployables, which is particularly helpful if we're deploying into the cloud or into some other mechanism where it might be expensive to send massive artifacts around. So JLink is a very interesting feature that I think probably wouldn't have been possible without the Java module system. Right. Before we move on to language features in Java 14, are there any questions that I can take right now?
There's one question. Next to the language improvements, of course, there's lots of under the hood improvements. Is this also in the scope of your session now? Do you have time for it, or is it something to address elsewhere?
Sorry, hold on. Let me. I don't really know. Well, okay, sorry. Ask the question again, and I will think through the answer more carefully.
The question was if there's time in the session to address the non-language improvements between Java 8 and Java 14.
Yes, okay. So we are going to, I will cover some of that. I will talk about some of the benefits of migrating. That includes some of the non-language features. I'm not going to go into it in depth because it's very difficult to like spin up an application and use a different garbage collector and show what that looks like. But I will be covering some of those, and also in the questions, I'm happy to answer questions around other stuff that isn't just things I can demonstrate in IntelliJ IDEA.
Yeah.
Okay, so language features in Java 14, which is the latest version of Java, soon to be replaced with Java 15 because they like to keep us on our toes, so we have to keep up to date every 6 months. In Java 14, we have switch expressions. They were introduced as a preview feature in Java 12. In Java 14, these are a fully fledged, fully production-ready feature that we can be using. Switch expressions are quite nice. If you've been using Kotlin or one of these other languages, you've probably already been using switch-style expressions. If you're using Java, you probably don't use switch statements because switch statements are really ugly and nasty and a sign that you're probably not doing something right with your object-oriented design. However, they are sometimes important, particularly in terms of parsing information which comes from the outside of your system, from a user, from a database, from another system. Sometimes we just can't avoid having a switch statement to kind of figure out how to turn it into something helpful for our system. Now, in Java 14, we can replace the switch statement with a switch expression. And we use significantly fewer lines of code. We can use a nice Lambda-like arrow. We don't have to have break statements. It doesn't look like code that comes from 1995. And I can even return values. Let me turn that back to what it was. With a switch statement, I have to set up my variable up front, and it has to be variable. And then I have to assign it here. I can't have it as final because it gets assigned later on in the code, obviously. So have I done wrong? Oh, in this case perhaps. But with a switch expression, the switch expression returns the type. So actually I can just inline that, get rid of all of that. And so I can actually make the most of some immutability there. I can also put, well, I had 2 cases before, I can have 2 cases in there. I can do more complex things. So I can do things like, I don't want to split those values. What do I want to do? I can do things like do something useful here. So I can do more logic in here and or extract it into a method. We use the keyword yield to return something from a switch expression. So yeah, so anyway, that's switch expressions. They are they're quite helpful and much more succinct way of writing code. I wouldn't go mental on it because underneath the covers, it's still just a massive if-else statement. It's still a tiny bit of a sign of a smell of your of polymorphism / object-oriented design. But if you do need to use something like this, it's just a much prettier way of doing stuff. All right, so yeah, so that's a fully functional production-ready feature in Java 14. Also in Java 14 is text blocks. Currently in Java 14, it is a preview feature. Now, I can't remember which version of Java introduced preview features, but it's definitely after Java 8. The idea is with these 6 monthly releases, now we have the capacity to introduce features which are not set in stone. They're not necessarily production ready, but they have been thought through and put into the language. You use a flag in your build system or in your compiler to turn on the ability to use preview features, and then you can play with some of these new features. Generally, it's not recommended to use preview features in your production code because they will likely change in the next version of Java. Text blocks, for example, was introduced in Java 13. It changed slightly in Java 14. It will be a production feature in Java 15, which means that you can actually use it in Java 14 and it won't change by the time Java 15 comes around. You can use it properly, as it were. Text blocks are a really nice feature, actually. It's a simple thing, but it's one of those simple things that you need to get right. Otherwise, it's just going to be a bit of a mess. So text blocks. We've all seen code like this. Often we have code, particularly I think for SQL statements, but we can have code of different types inside our Java code. We can have things like often JSON strings or maybe other languages like JavaScript. And we have to have all these escape characters and it's all just a little bit hairy. Now with text blocks, you basically start your text block with 3 quotations and you end it with 3 quotes. And you don't need to escape anything in here. Anything that you put in here is just basically a literal. So, and the formatting matters as well. You can see here, there's a line here, which is the sort of start of the formatting for this text block. So if I move that forward, this white space is significant and it is part of the string. So it's really helpful for things like this kind of thing. What else? So HTML, we can do it with our HTML. We can do it with our SQL. Like I said, I think it would be useful with something like JSON in IntelliJ, because I do work for JetBrains. We do create IntelliJ IDEA, so I will occasionally show some features of IntelliJ IDEA. You also have the ability to inject a language, like here I could inject JavaScript, and then I get code completion and highlighting inside that text block as well. So I can actually play with this as if it was really JavaScript, which is quite nice. So text blocks just enable that. It just gets rid of a lot of the noise around having to escape all these special characters. And that will be a fully fledged feature in Java 15. It's currently available in Java 14. Records is a new preview feature that came into Java 14. You'll see that all of these links here are blog posts that are Java 14 and IntelliJ IDEA. The reason being that a lot of them were written by my colleague Mala Gupta. She does a fantastic job of summarizing what the feature is, in this case, records. Obviously, the context is IntelliJ IDEA because we do work for IntelliJ IDEA, but this is the best resource I found for like introducing a person to the new feature. For example, in this case, records. Records is really nice. I was one of those people who was not that bothered about what we call boilerplate. I don't really care if my class has got getters and setters and constructors and whatever. I'm just kind of been doing Java for 20 years. My brain just tunes it out. So I was not super unhappy about that. Having said that, I'm very excited about records. They're so cool. So let's create a new user, which is a record. And then my user, I can have something like a string name. And again, if you've been using something like Kotlin, you'll know Kotlin data classes already do this. This is basically Kotlin data classes for Java, int ID, something like that. And I don't need to do anything else here. This will automatically have getters, not setters. It'll have getters, a constructor, a toString, hash code, and equals. So all of that stuff is just kind of basically generated under the covers for me. So I don't need to do any of that. If I want to, I can override those things. So I can generate a constructor. Let's generate what is called a canonical constructor, because that's what we're used to seeing. We might want to do this, and we might want to do something like, do I have a validation somewhere? There we go. Oh, I don't want to do that there. Let's put it down here. I might want to do something like validate my fields, and then use the constructor. So I might still want to override the constructors. I actually don't need what's called a canonical constructor here, because this is just the default one, so I can convert it to a compact form, and I don't need to put anything in there. It just automatically picks all these record components up from this declaration at the top of the file. So that's really cool. And what else? Another interesting thing about records is that my getter is let me generate them, is not called get anything. My getter for name is not called get name, it's just called name. And that's kind of a bit of a change from the standard for Java, but I think it's kind of cool. So let me have a look at record test. I'm going to run this test and show you what the what it actually looks like, the fact that it's got a toString, hash code equals, etc. So if it's going to run, oh, I should have run this beforehand, so everything was cached in my IDE. Okay, so yeah, so I get a pretty toString and stuff like that. So I've been using this a lot since 14 came out. I've been using it a lot in testing. Anywhere where I'm sort of building up my domain model, I will start by creating something with a record, because mostly I don't want to put in heavy domain logic into my original objects to begin with. If I'm creating like I've been working on something which has got grids, if I'm creating a row, my row doesn't really have anything in it, so my row makes sense to have it as a record. So that's records. This will be, it's going to be changing in Java 15, so it's not quite ready yet, but it's something we can play around with in Java 14. Pattern matching for instance of, also a preview feature in Java 14. What is the time? I suppose I should probably hurry up. Pattern matching for instance of pattern matching. This means that in the olden days, i.e. Java 8, I do an instance of, and then I still have to do a cast, which is kind of, it's not the end of the world. It's kind of fine, and we can get the IDE to generate that for us, but it's just a little bit unnecessary when inside this block, I know for a fact that this person is an employee. So, so with pattern matching for instance of, I just create a pattern variable. So I say employee, employee, and then I can use the employee in here like an employee. So it's just a really nice feature. Pattern matching, this incidentally is the start, I think, of a bigger a bigger number of features around pattern matching. So we can, there's a proposal for pattern matching around switch expressions. You can use pattern matching for a whole bunch of stuff just to kind of reduce some of the boilerplate around when we know a particular thing is a particular shape. We don't have to cast it or smoosh it into a different shape. So I don't really know exactly what that's going to look like, but it's definitely work in progress under Project Amber, I think. And this will be pattern matching for instance of is not going to be changed in Java 15, so it looks fairly stable. It's still going to be a preview. So yeah, so let's talk a bit about beyond Java 14. That's all the features that you're going to get if you use Java 14. In Java 15, which is coming out in September, so by the time some people watch this video, Java 15 will be out, and I'll be recommending you need to use Java 15. By Java 15, text blocks will be a standard feature of the language. Like I said, the version that's in Java 14 is already stable. It won't be changed in time for Java 15. So it's what you've got in 14, you will have in 15 as a standard feature. Pattern matching for instance of will be the second preview in Java 15. From what I read today, it's not going to be changed. It'll be the same functionality, but it will still be a preview feature. Records will be a second preview. I can't see exactly what's different about records, but I think part of it is how it's going to work with sealed types. So sealed types is a new preview feature, which I really hoped to demo today, but have not. I don't have a demo ready in time for that. So sealed types is the ability to say from my class or interface, like, I don't want any old person to inherit from me. I only want a subset of things to be able to inherit stuff from me. So it's quite good from a sort of security point of view, hence the word sealed. Hidden classes is coming in 15 as well. So classes that can't be used outside of the library or the API, I guess. ZGC is another garbage collector. There's been experimental versions of this in the versions of Java which are available now. In 15, it will be the production-ready ZGC, so that will be available for use in 15. If you want to have a look at everything that's available in 15, then that's your URL. At the end of this talk, there will be a single slide with a URL which has a link to all of these things, so you don't necessarily need to sort of screen grab all of these things. In the future, you can see from, so I haven't broken down every feature into every individual version of Java because that gets kind of tedious, and you don't really care what came in 12 and 13 and 9 and 10 because you're not going to use 12 and 13 and 9 and 10, you're going to use 11 or 14. But you can kind of get the feeling that Java is moving forward. Yes, since 8, there haven't been any like major language changes the same way streams and Lambda expressions were, but instead what we have is this really nice incremental change of features which actually matter to us as developers. Some of these small changes that actually just make code a lot easier to write. Things like var, things like pattern matching for instance of, things like switch expressions, things like records. They're kind of small-ish features, but we get like a new one every 6 months, and they make it a lot easier to actually just write code and just get on with the job of delivering value for the business. But you know, the whole point about a Java developer is not to be writing Java code. The whole point is to be actually implementing something so that someone else can make money off it. And that's kind of going on. So in the future, Project Amber is a project around reducing the boilerplate in Java. So a bunch of stuff has already been done. A lot of the features you've seen here, var and so forth, came under Project Amber. There are other features here, I think around pattern matching, for example. Records comes under Amber as well, I think. Valhalla is about, it includes value types, which is kind of interesting. It's also doing some work around generics. And so there's a lot of under the cover stuff happening there, which could be interesting from a performance point of view. It's going on, but we haven't really seen any of that coming into the JDK yet. Loom, I think, was mentioned in the previous talk. Is about fibers, continuations, and tail calls for the JVM, apparently. So Loom is about lightweight concurrency. So that's really interesting for us in the Java world. There will continue to be a bunch of garbage collection improvements, and there is a proposed new project, Project Leiden, which is around addressing the startup time of Java. So I don't want to speculate much about that, but the whole point is a whole project just around trying to make it as quick as possible to start up your application. Now, we care about language features, but the business doesn't care about language features. You can't sell the business on we should be moving to Java 14 because now I can use var and switch expressions. They really don't care about that. So how can we sell this to the business if we want to? What are the benefits to your application, to the business, to your users? Well, primarily the main improvement with every version of Java, particularly the big releases, is you generally get better performance with every version of Java. You get continued improvements to the JVM, so not language features, just stuff that happens under the covers. Things like the way that streams were implemented, the whole idea was that the JVM could take care of the performance of that, particularly around parallel streams, and you don't have to see it. So those things can be happening under the covers. Runtime optimizations, use of CPU instructions, that kind of thing. So generally speaking, you will see your application will perform better on a newer version of the JVM without any changes, without doing anything. I don't have it in this deck. I did have a link for the difference in performance between 8 and 11, and under some circumstances, the specific benchmarks they had, it is interesting, it is useful. Related to that is use of memory. So things like compact strings and a bunch of other features allow, because the JVM doesn't have a great reputation sometimes for like hogging all the memory that's available to it. And particularly when you're talking about cloud or virtualized environments, it's not always great to do that. The JVM has enormously improved in this area since Java 8. A lot of work has gone around the use of memory, efficient use of memory, and things like compact strings and so forth. And on top of that, a lot of work, again related, a lot of work has gone on in garbage collectors. So the default garbage collector is now G1. In actual fact, I don't have it here, but the previous default is or has been removed from the JDK at the moment. So G1 was made the default GC. Lots of improvements have happened over G1 to G1 since Java 8. Also, the introduction of 2 new garbage collectors, Epsilon and ZGC. I suppose it should be ZGC, but I'm English, so it's ZGC. These were new experimental garbage collectors introduced in Java 11. In Java 14, you have access to Shenandoah, which is another experimental garbage collector, and even more updates to the various different garbage collectors. Now, I found this a little bit intimidating because it's like, well, I don't really understand why I need all these different types of garbage collectors. If G1 is now the default, if we're deprecating the old garbage collectors and introducing new ones, like I don't really know which one is the best. But the point is to have a range of garbage collectors to match the different types of profiles of your application. In theory, to move away from the days of you having to tailor every single flag on your single one-size-fits-all garbage collector, and instead you're going to pick a garbage collector which best suits the performance profile of your application. So I think that's very interesting. And of course, I guess some of this is OpenJDK, but of course other vendors have their own garbage collectors as well, so there might be some other work going on in that area. Another thing that the business is particularly interested in when it comes to upgrades is cost, preferably reduced cost. So obviously, if you are using less memory, if you're producing smaller deployables because you're using JLink, because you're using the modular system, if you have better performance and you're running in the cloud, this will lead to cost savings often. You might have to do some experiments to find out whether they're significant or not. But there's another interesting cost here, which is not just about money. There's a cost in terms of recruitment and retention of your staff and of your talent. So there will come a time, now we're on sort of Java 14, Java 15, there'll come a time when it's going to start getting difficult to recruit developers to work on applications which are only Java 8, the same way no one wants to work on Java 6 applications anymore. There will come a time when you're going to want to use newer language features in your application so you can attract and retain the sort of talent that you want on your team. So there's a kind of a recruitment cost potentially involved with this. And as obviously with the new releases coming out every 6 months, this is just going to get worse with time. And on top of that, it's going to become increasingly difficult to become up to date. If, for example, you decide, okay, well, I'm not really sure about Java 11 because there really aren't any major features that are coming into Java 11 that are interesting to me. I don't want to go to Java 14 because it's a 6-monthly release, which is going to be replaced. Maybe I'll wait for Java 17. I think you want to think really carefully about the cost of migrating from 8 to 17, because you're talking 2 major releases there, and during that time we're talking about deprecations, removals, and infrastructural changes. So it's really a good idea to try and upgrade sooner so you can do it more gently than a big bang upgrade it'll be next September at this rate. So while we're on that, I'm just going to go through some really quick tips for migration. This is not a talk about migrating your JDK. It's more kind of high level things that you might want to think about. If you have been sold on my idea of updating, then these are the sorts of tips that you might want to think about, and also go away and read and do some more homework. So first thing to do is run your application, not compile, run your application on an updated JDK. It might just work. I have done it with a couple of open source projects. Granted, they were smallish, but they did just work. It was surprising. I think this is going to become less and less likely with more recent, if you move further and further away from Java 8, but it might just work. The first thing you really want to do if you're serious about upgrading is you want to address your compiler warnings. So when you compile stuff in IntelliJ or Gradle or Eclipse or whatever, you do get a bunch of compiler warnings, usually like forever. even clean projects have compiler warnings. They are there for a reason. Often they as of Java 8, there's a bunch of warnings in there which says these features are going away or are changing. So please do something about it before you update your version of Java. So address compiler warnings, address deprecation warnings. Deprecation has changed in this new world order, and in Java will actually delete stuff now. I know in the past they always just kind of deprecated stuff and you can just carry on using it forever. And that's not the case. A bunch of stuff got removed in Java 11. So you want to take deprecation warnings seriously. So yes, address your compiler warnings and your deprecation warnings. They are there for a reason. They do mean something. On a related note, update your dependencies. Particularly moving from 8 past 9, you want to make sure that all of your library dependencies are updated. So all of your versions of your Springs, of your Mojitos, of the stuff that you use all the time, you really want to make sure that they're up to date. You should be doing that anyway for security reasons. But if you want to migrate your version of Java, first, one of the earlier things you need to do is update your dependencies before you update your version of Java. You will probably need to add some new dependencies. In Java 11, they removed some of the Java EE code from Java 11 because it really shouldn't have been in the JDK, but it was. So you might need to add some dependencies, particularly for JAXB and a couple of the other Java EE things. It's just one more dependency, but you may need to do that. Add that as an explicit dependency. JavaFX as well. JavaFX is now no longer part of the JDK, so you need to add that as a separate dependency. You will need to update your build tool. I highly recommend this. The current version for Maven is 3.6.3. The current version for Gradle is 6.5. If you want to use Gradle in Java 14, you will have to use Gradle 6.3. It does not work on an earlier version of Gradle. So you have to update your version of your build tool, whether it's Maven or Gradle. And then when you have done all those things, then you can try compiling against the updated JDK, and then you can start using the shiny new features. Now, me with my developer hat on, I'm like, that's the first thing I want to do. I want to compile it against the new JDK and use the shiny new features, but really you do need to take the other steps first. I have written an article about upgrading Java 8 to 12 because I wrote it last year. So there are some more detailed tips in here about how to identify your dependencies and how to figure out some of the steps to take. So if you're interested, then it's worth looking at this. In summary, Java is changing, and it is changing fast. Granted, there are not some of these big new features, but instead we're getting a lot of little nice new features quite frequently. Modern Java can help you. It can help you with performance, it can help you reduce the cost, it can help you with maintenance. Readable code is maintainable code. So some of this stuff which is all about readability and reducing boilerplate should save you effort and cost in terms of maintenance. There are two main upgrade options if you want to move off Java 8. To upgrade to Java 11, which is the current long-term support release, or to upgrade to Java 14 and potentially accept the fact that you'll have to upgrade every 6 months from then on. I do suggest, though, based on I'm a developer advocate, like you don't have to listen to me, but I do suggest that you upgrade sooner rather than later, so you don't have a big bang upgrade at some time in the future. So it's a good idea to upgrade, I would say, to 11, and then potentially you might even want to keep running your application against the 6 monthly releases and continuous integration or somewhere like that to at least test that nothing's going to be broken going forward. So yes, so there you have it. At this link, you will find, you're supposed to find my slides, but I couldn't upload them for some reason. But this link, you'll find the old slides for this talk. You'll find videos of this talk. You'll find links to all of the features that I've talked about, links to all of the documentation that I've talked about in terms of like my article for doing migration and stuff like that. So, so yes, feel free to take a look at that. And I guess there's time for questions. This took way longer than I expected it to.
Yes, we had lots of questions and interesting discussions on the chat, so I will make a selection out of those. There's a question about switch expressions. Could you elaborate a little bit more about the use of yield instead of return and the absence of the break?
Curses, I was really hoping no one would ask that. Actually, let me put this here so that this link is visible. Yes, so there's a boring answer and longer answers. That let's go back to switch expressions. And let's turn that back. Can I do it automatically? Replace with old switch statement. Oh, that was actually doing a return. I don't want to do that. I will answer the question in a minute, I promise. Right, so the old switch expressions use a break to break out of it. In the early version of switch expressions, they said that you could do break as the return from here. So let's see, let's open this up here. So the original intention was to say break there, because that's consistent with what the switch statement used to do. A lot of people kind of found it sort of weird, so they actually changed that to yield. So it is what it is. I spelled that wrong. So that's the word they chose. I guess they chose it. I don't really know. I do know they chose it deliberately. You generally are not going to see that unless you have a more complex expression here. Do something useful. That's about as far as I can comment on that.
Okay, thank you. There's questions around the immutability of record, and also if they will be mutable through reflection, maybe for frameworks like Lombok to set the values.
I think, I don't know the answer to that. I do know that when I was reading about records today with regards to Java 15, there is some work going on around records and reflection. I actually don't know what the current state is, and I don't know what the intended state is. So yeah, it's a good question. It's definitely something that's under discussion at the moment.
Okay. I think a nice final question is, with all the new changes entering Java, do you think languages like Kotlin will be less prominent?
That's a really good question, given that I work for the company that invented Kotlin. I think Java has enough use and momentum to be around for a long time, right? And there are plenty of organizations that will be happy to see that Java is updating quickly, that it's introducing new features, so they don't have to move to Kotlin, for example. But I think there are also plenty of other types of organizations and different types of projects where a language like Kotlin is more interesting. So for example, lots of people are using Kotlin on Android because the Android platform is a different sort of platform. Lots of people are happier to move to Kotlin because it gives them the features that they want, and it's a slightly different. It's not tied into Oracle. It's not tied into OpenJDK. It's got a different governance and a different release process. So that can be a positive for some people. But similarly, there are plenty of organizations that don't want to move to another JVM language. They want to be using the Oracle one because better the devil you know. I see them, I genuinely see them being very symbiotic. So I've been working for JetBrains for 5 years. When I started working at JetBrains, Kotlin was fairly new. It'd been around for a while, but it didn't have the same sort of mind share that it has right now. Kotlin now is going wild. Lots of developers, every time I talk about new features in Java, people are telling me, but have you heard of Kotlin? I'm like, yes, I know about Kotlin. So it's very popular, and it's increasing in popularity, but it's not going Kotlin isn't going to overtake Java, and Java isn't going to replace Kotlin in some of the places where Kotlin worked really well. In the same way that that Groovy kind of slowed down for a bit, but Groovy is still an amazing language for so many things. I still really like to write my tests in Groovy. It's just a very expressive, pretty language, and there's always going to be a niche for that sort of thing.
Yeah, so there's enough room to have multiple languages. And
Definitely.
maybe it's also good to have a little bit of competition to advance the language features.
I think what's happening right now is, like I said, it's a really nice symbiosis whereby there is a little bit of competition. So when Kotlin comes along and has a really nice feature like data types, data classes, Java can go, oh, we'd really like that. But then you can kind of like, they benefit from it. You can kind of steal it, make it more Java-y. The fact that we have var, but not val, we have final var, makes it more Java-y. You know, I think that it's kind of nice to have a little bit of tension, a little bit of competition, but ultimately, we seem to be using that in a way that's really driving all the languages forwards rather than, because of course Kotlin and Java are entirely interoperable. So you can write some code in Kotlin and some code in Java and have them talk to each other. The same with Groovy. So they're not really that competitive. You know, they can actually just coexist really nicely.
Okay, thank you. And thanks for sharing your experience and answering all our questions. This was the last session of today. Please join us tomorrow at the same time and location. We have Brian Vermeer talking about dependency management and Graham Roger talking about Micronaut. And if you want to show off your attendance, you can buy our JSpring t-shirt. It's available from our website. And of course, you can stay around in the chat, talk to other participants, talk to the speaker. Have a great evening and see you tomorrow.
Om die enorme geld- en informatiestromen in goede banen te leiden, is een betrouwbare en geavanceerde infrastructuur nodig. En die wordt in de lucht gehouden door een organisatie die achter de schermen zijn werk doet. Belastingdienst Directie Informatievoorziening. Of kortweg IV.